Alright, okay, so this is a summary of Sn1 versus Sn2, okay. So Sn1 kita tahu dia adalah unimolecular. Apa maksud unimolecular tu? It means that it is a first order reaction. So when you look at the rate equation, okay, kita tengok Sn1 dulu. Rate equation for Sn1, your rate depends on the haloalkane only, satu molekul. So itu yang dimaksud dengan unimolecular. Okay, so maksudnya satu je lah molekul yang akan affect the rate of reaction. So the strength of nucleophile, okay, does not affect your rate. Okay, so in Sn1 you will form carbocation. Okay, so maksudnya awak akan form stable carbocation. So basically macam tertiary carbocation, okay, secondary carbocation, okay. So if you have a primary carbocation, boleh ke? Dia depend, okay. Kalau awak punya primary carbocation ni, awak punya haloalkane ni, boleh rearrange untuk jadi secondary carbocation atau tertiary carbocation, okay, using 1,2-methyl shift atau 1,2-hydride shift, then it can undergo Sn1. Alright, tapi kalau tak boleh. Okay, so we're going to look at Sn1 mechanism. How does it look like? So Sn1 mechanism, awak jangan confuse yang 1 tu maksudnya step. 1 tu maksudnya dia adalah unimolecular. Okay, okay. Tapi Sn1 dia ada 2 step. Okay, so the first step is you're going to form your carbocation. Okay, so dalam Sn1 awak akan first form carbocation. How are you going to form? Basically awak punya leaving group will leave. Okay, so here we have a tertiary haloalkane. Awak punya leaving group will leave. This is a slow process or the rate determining step. So basically in this process here, okay, formation of your intermediate, right, it only involves your haloalkane. So that's why awak punya rate of reaction, awak punya rate law, okay, tadi tu K, okay, depend on haloalkane awak je, bukan nucleophile. Sebab dalam this step, this rate determining step, tak ada pun nucleophile awak, kan, ni haloalkane je ada. Okay, so lepas tu kita pun dah form lah tertiary carbocation yang sangat stable. So that's why tertiary haloalkane will most definitely undergo Sn1 mechanism. Okay, alright, and then we have our leaving group X minus. Okay, so next step is you are going to use your nucleophile. Okay, whatever nucleophile, contoh OH minus ke, okay, datang dari sini, dia akan attack awak punya carbocation. Okay, carbocation kan electrophile, jadi dia kena attack lah. Right, so nucleophilic attack in Sn1, note it comes from front. Okay, so macam mana nak tahu front ke back ke? Awak tengok balik kat haloalkane awak ni. Ini yang attach dekat bahagian yang attach dekat halogen ni adalah front. Okay, so yang kat belakang ni, belakang lah, back. Okay, so Sn1 mechanism memang awak akan attack from front. Okay, kenapa awak attack from front? Sebab awak ada these CH3 groups kat belakang. So awak punya nucleophile tak boleh attack kat sini sebab dia kena block. Okay, namanya steric ni, awak kena block ni. Okay, so macam tu in Sn1, nucleophile attack from front. Okay, so this is a fast reaction. So awak pun dapatlah awak punya produk. Alright. Okay, so ingat ini just a summary. So in Sn1 you will use weak nucleophile, contoh macam water and whatever we will see later. Your nucleophilic attack is a front side attack, daripada depan. Okay, bahagian depan dia attack terus kat carbocation dekat depan ni, bukan kat belakang. Okay, and your intermediate is a carbocation, this one here, yang awak form dalam step 1 ni. Okay, Okay. So this is the increasing reactivity order of haloalkane. So siapa yang paling stable, siapa yang paling favor Sn1 mechanism ni, they are tertiary dengan secondary haloalkane. Okay. Primary haloalkane kita kena tengok ada steric hindrance ke tak. Kalau ada, kalau dia boleh rearrange jadi a more bukan steric, sorry nak. Kalau dia boleh rearrange jadi a more stable carbocation macam 2 ekor ni, then dia boleh lah undergo Sn1. Kalau tak, jangan mimpi lah. Okay. So in Sn1 mechanism, steric factor is not important. Okay. Maksudnya in Sn1 mechanism, kita akan tengok the stability of your carbocation. Okay. Okay, so now we're going to look at Sn2 mechanism. So Sn2 maksudnya bimolecular. That means that for rate of reaction, your rate depends on haloalkane and your nucleophile. Okay, so that means that in your dia dalam proses tu, rate of reaction tu, dua-duanya ada. Okay, so the process of bond breaking and bond forming occur simultaneously. Okay, dua-dua tu ada. Bila dia ni nak break bond dia dengan living group tu, dengan dia ni nak form bond dengan carbon awak. Okay, in Sn2, the nucleophile will attack at the site opposite to the halogen. Ini maksudnya backside attack. Dia attack dari belakang. Okay, kenapa? Sebab kita nak minimize the repulsion lah. Okay, so the intermediate species will be an activated complex. Okay, since the rate of reaction depends on nucleophile, therefore if you use a strong nucleophile, then the rate of reaction is higher. So that means that Sn2 mechanism ni selalunya awak akan guna strong nucleophile. Memang akan guna strong nucleophile. Okay, bila awak guna strong nucleophile, awak akan favor Sn2. Okay. Alright. So Sn2, okay. Sn2 is a one-step reaction. Okay. Dia terbalik lah. Tu ni bukannya maksudnya step ya. Tu ni maksudnya berapa molekul yang involved in your rate determining step. Okay. So dia ada satu step je terus. Okay. Apakah step itu? Stepnya adalah, okay, nucleophile awak. Okay, awak ada haloalkane. So carbon ni susceptible to nucleophilic attack. X ni adalah more electronegative. Okay, so dia ni akan kena attack dengan nucleophile. So your nucleophile will attack from the back. Okay, ni belakang, ni berdepan. Dia attack dari belakang. Okay, dia attack dari belakang sebab awak punya haloalkane ni dekat part belakang tak ada steric hindrance. Okay, so awak ada satu je R group. So dia tak block lah untuk nucleophile awak attack daripada belakang. Kita suka attack dari belakang sebab ini akan minimize repulsion. So ini negative charge dengan ini pun high electron density kan. So kita nak minimize repulsion. Okay, so in Sn2 mechanism, you have to remember some important things, which is to draw, okay, show the tetrahedral shape, okay, at carbon ni. So awak kena tunjuk, okay, tetrahedral. One more thing, you have to draw it in 3D. So that means that you have to show this wedge, okay, dash wedge ni dengan solid wedge ni, okay. Awak kena tunjuk dalam 3D dengan tetrahedral. Alright. And Sn2, your nucleophile attack from the back, dari belakang. Ini front. Okay, itu Sn1 kalau attack dari front. So what happens here is that your nucleophile will attack carbon. At the same time, your leaving group wants to leave. Okay, so this is a slow process, your rate determining step. What will affect your rate lah? Dua ekor ni, nucleophile dengan awak punya haloalkane. Okay, Okay. So then kita akan form an activated complex. So activated complex, you have to draw it this way. Okay. 3D. And then sekarang, since nucleophile ni nak form bond dengan carbon, this bond is forming, tapi dia belum lagi jadi bond yang betul. Okay. Ini still transition state. Dia tengah transit. So this bond, CX bond here, okay, is breaking. Okay, tapi dia belum betul-betul break. Okay, dia still ada. So you have to show nucleophile, carbon dengan halogen ni, awak kena tunjuk dia align. Okay, kena tunjuk Alright. So tunjuklah kat sini, ini activated complex punya symbol. Right. So what's going to happen next is, okay, dari sini kita akan dapat produk kita. Okay, kita akan dapat produk kita. This bond will form. Nucleophile dengan carbon ni punya bond akan form, and this bond will break. Okay, so kita pun dapat nucleophile bond dengan carbon and no more X. So X tinggal kat sini, dia jadi living group dah. Okay, so here what you have to notice is that this product, okay, dia punya configuration, dia punya kedudukan is inverted. Okay, dah terbalik. Apa yang terbaliknya? Apa yang terbalik is that awak ingat umbrella. Kalau kat sini awak punya umbrella macam ni, kan? Awak punya substituent kat belah kiri. Okay. Sekarang, because of this back attack, awak punya molekul ni akan kena tolak ke sana. Kena tolak ke sana. Sebab tu kita sekarang, kita punya umbrella terbalik. Bukan umbrella terbalik. Dia macam umbrella yang kena tolak dengan angin. Kan? Dia jadi macam ni. Okay. So sekarang nucleophile duduk sini. And then your substituents, your hydrogen duduk on the right side. Okay. Because of this back attack. So ingatlah the few stuff that you have to remember. Okay. Untuk Sn2 mechanism, you have to draw macam ni. We will look at it in more detail later. Alright, so note that strong nucleophile will promote Sn2 mechanism. So asal awak ada strong nucleophile, awak akan undergo Sn2. And the nucleophilic attack is from the back. It is a backside attack. Okay. The intermediate that is formed is an activated complex. Okay, this is your activated complex. And siapa paling favor Sn2 mechanism? Your methyl halide, your primary haloalkane, or your secondary haloalkane. Tertiary haloalkane most definitely will not undergo Sn2. Okay, because of steric factor. Okay, dia adalah sterically hindered. Kita akan tengok after this.